So in this transfer task, we see if students are able to apply what they learned in the lesson to a new context. So here, the context is we have an expression for the area of a regular polygon, and it's r squared n over 2 sine 360 over n. And we're trying to show that that approaches the area of a circle as n approaches infinity. So students know that the area of the circle is pi r squared. Both sides having r squared means that this uh, factor here would have to approach pi as n approaches infinity. So here are some student exemplars, and I'll just say what I liked about each one of them. So basically here the student starts off with the area of the circle being pi r squared, and then commenting on the area of the regular polygon. Since both areas have r squared, which is an important piece, we need to show that pi is approximately equal to n over 2 sine 360 over n. And then understanding the limit concept, that as n increases, it gets closer to pi. So pretty simple, but just understanding the structure and also the limit concept in this problem. Okay, this next student, same thing, says the area is r squared, and then you can see they put the box around the part that's going to approach pi. So this must be approaching pi but never reaches it, or else it would have the same area as the circle. So this student, I'll say, did a good job of emphasizing the structural part. They don't have as much in terms of saying why this must approach pi, but at least they're able to see this expression structurally. Okay, this next student, again, shows the area of the polygon, shows the area of a circle, shows that r squared equals r squared. Therefore, the part that's left is that part that must approach pi as n approaches infinity. So again, just showing that they're able to parse out the structure and then make the limit argument. Okay, another student here, area of the circle is pi r squared. And they say since the r squareds cancel out, okay, not as precise, but at least understanding the idea, then what's left over after the r squareds quote unquote cancel out should approach pi. Okay, and then finally this student, area of the circle is pi r squared, and they're saying n over 2 times sine 360 over n will approach pi, but it will never get there because r squared equals r squared, and n over 2 sine 360 over n equals pi when n equals quote unquote infinity. So again, for 9th and 10th grade geometry students, to be making these kind of arguments, I was frankly pretty impressed. It's more than I was doing in 9th and 10th grade geometry. So yeah, that's why we call these exemplars. Anthony Carruthers, Better Lesson, Master Teacher Project.